This is an AQA GCSE Coordinated Science Chemistry question. Have a go at each section, pausing as you go, and then review your answers. So here's parts A and B, parts C, parts D and E, and finally part F, taking us to a total of 11 marks. So let's go back and review the answers for part A. What order did scientists use to arrange elements in early periodic tables? This is a really important one, and I've highlighted the key word. It's the atomic weight. Now, we don't talk about atomic weight on the modern periodic table at all. We are only going to use that term in historical context. In the early periodic table, some elements were placed in the wrong groups, but Mendeleev overcame this in the periodic table. How did he do it? Well, one of the key things he did was leave gaps for elements not yet discovered. That allowed the other elements to be nudged into the correct place in the correct groups with similar elements. Moving on to part C, we have got here fluorine, chlorine and bromine and their boiling points. And we are asked why the boiling points in the table are low. So we're actually moving into a bonding section here. This is from the bonding topic. And you need to remember what type of compound and what type of structure the halogens are. And once you remember that, you can think about why their boiling points are low. So they are molecular covalent. That means they have weak intermolecular forces. And if the intermolecular forces are weak, that means not much energy is needed to overcome them. It's really important that you remember that with molecular covalent compounds, it is the forces between molecules that you're overcoming. You're not breaking the bond within the F2, the Cl2 or the Br2. Moving on to part D, explain the trend in the boiling points of the table above. Now what you notice, going back for a second, is that as you go down the group, the boiling point gets higher. That's because the molecules get bigger as you go down the group. Why would that have an impact? Well, if the molecules are bigger, that means there are more or stronger intermolecular forces. And if that's the case, more energy is needed to overcome them. So the melting point increases. They won't boil until you reach a higher temperature when the extra energy is there. Moving on to part E, explain why neon is unreactive, but it also tells you to give the electronic structure of neon in your answer. It's amazing how when you race through a question, you might miss something like that, but neon has an electron configuration of 2,8. Why is it unreactive? Well, we only have 1 mark left now. It's because it has a full outer shell. In slightly longer terms, that means that it doesn't need to lose or gain or share electrons to get a full outer shell, and that's why it's not reactive. And finally, on to part F, how many atoms are there in 1 gram of argon? And we're provided with Avogadro's number here. Now, Avogadro's number is the number of atoms or molecules that exist in 1 mole of any substance. So if we know how many are in 1 mole, the first job we have is to find out how many moles there are in 1 gram of argon. And to work out moles, you do mass divided by molecular mass. The mass is 1, we can see that from the top line, and the atomic mass actually here, because it is an atom, is 40. So we do 1 over 40. If 1 mole has 6.02 by 10 to the power of 23 atoms, that means 1 gram has a 40th of that based on what we've just done. So I do 1 over 40 multiplied by Avogadro's number. And that takes me to the final answer, 1.51 by 10 to the power of 22. That takes us to the end of this question. Thank you for listening.